Hello students, in the last class we discussed about the dichlorine preparation and its properties. Then next important compounds of halogen is hydrochloric acid. Hydrochloric acid formula is HCl. Then consider the preparation of the HCl. HCl can be prepared. HCl can be prepared by treating sodium chloride by heating the sodium chloride with concentrated H2SO4. By heating sodium chloride with concentrated H2SO4, that is reaction is NaCl sodium chloride plus concentrated H2SO4 at a temperature of 420 Kelvin. We get NaHSO4, sodium hydrogen sulfate and HCl. The formed sodium hydrogen sulfate NaHSO4 further reacts with sodium chloride. That is, if you further heat to 823 Kelvin, we get sodium sulfate Na2SO4 and HCl. This is the preparation of the HCl. That HCl, formed HCl, that can be dried by using concentrated H2SO4, because H2SO4 is a more dehydrating agent, drying agent. Hence, formed HCl can be dried by using concentrated H2SO4. This is about the preparation of the HCl. This is two steps: NaCl plus concentrated H2SO4, sodium hydrogen sulfate, and traces of HCl is formed. That formed sodium hydrogen sulfate further heated with NaCl at 823 Kelvin, then we get the HCl. That can be dried by using concentrated H2SO4. Then you study the properties. HCl, it is a colorless gas. HCl, it is a colorless gas with pungent smell. That HCl is soluble dissolved in water. HCl is dissolved in water to form the H3O plus hydronium ion and Cl minus. For this reaction, Ka value is very high. When HCl dissolved in water, it donates the proton, that is forms the hydronium ion and Cl minus. Ka value for this reaction is very high. Due to very high Ka value, HCl, it is a strong monobasic acid. It donates only one hydrogen atom, hence basicity value is 1. HCl is a strong monobasic acid. Then you consider the reaction with the noble metals. To dissolve the noble metals, we are using aquaresia. Very most important for 1 mark. Aquaresia means the mixture of concentrated HCl and concentrated HNO3 in the ratio 3:1. That is, HCl is of 3 volumes and HNO3 is of 1 volume. If you write HNO3 and HCl, then 1:3, because HCl volume is 3 moles and HNO3 is 1 volume. That mixture we can call it as an aquaresia. This aquaresia the use of this aquaresia is used to dissolve used to dissolve the noble metals. Used to dissolve the noble metals like gold, silver, and platinum. To dissolve the noble metals, we are using the aquaresia. Aquaresia is a mixture of concentrated HCl and concentrated HNO3 in the ratio 3:1. Then in our syllabus, they are given the reaction, ionic reaction, that is for the gold, AU. Then acid, HCl and HNO3 are acids, hence you consider the H plus. From the HCl, Cl minus. From the HNO3, nitrate ion. They have mentioned the ionic reaction. Then gold dissolves in the aquaresia, form a complex compound, AuCl4 minus. AuCl4 minus. In that nitrate ion reduced to nitric oxide, liberating the water. Then to balance this reaction, consider 4H plus and 4NO3 minus. Then 2H2O. Reaction get balanced. This is the reaction with gold. Similarly, platinum, Pt, same, H plus, Cl minus, NO3 minus, that is nitrate ion. Then that platinum dissolves in the aquaresia, forms PtCl6 2 minus. The charges are very most important. Forms NO and H2O. To balance this reaction, 3Pt, then 16H plus, 4NO3 minus and 18Cl minus. Without balancing, we will not get the mass. You must and should balance the reaction. 3PtCl6, 4NO and 8H2O. This is about the reaction with noble metals. Actually, in competitive exams, the gold dissolves in aquaresia, forms HAuCl4. This is called as an chloroauric acid. Gold forms the chloroauric acid. If you separate this H, then H charge is +1 and hence this complex gets the -1. This HAuCl4 we can call as an chloroauric acid. Similarly, platinum dissolves to form H2PtCl6. This is called chloroplatinic acid. Chloroplatinic acid. This is the gold and platinum. If you remove this H2, hence you get H2PtCl6 2 minus. Or some books they can consider chloroplatonic acid. Also. Chloroplatonic acid. Or you can take chloroplatinic acid. Either platonic acid or platinic acid. Go for gold, chloroauric acid. You have to remember these names also for your competitive exam. This is about the reaction with the noble metals. In NCERT, they mention only these ionic reactions. Next, you consider reaction with the salts of the weak acids. The HCl will decompose salts of the weak acids. For example, you consider sodium carbonate. In the laboratory, we are using carbonate radical, that is sodium carbonate. To that carbonate, if you add HCl is added, you get brisk effervescence. That brisk effervescence are evolved due to liberation of the CO2. Hence HCl decompose sodium carbonate, and other one are NaCl and H2O. To balance this reaction, 2HCl and 2NaCl. This is the reaction with sodium carbonate. Similarly, HCl will decompose. HCl decompose that sodium sulfite into sulfur dioxide. To the sodium sulfite, if you add HCl, that sodium sulfite formula is Na2SO3. Sodium sulfite. If you add HCl decompose sodium sulfite into sulfur dioxide. Here also you get colorless gas, sulfur dioxide, then liberating NaCl and H2O. NaCl and H2O. Then to balance this reaction, 2HCl, 2NaCl. This is the reaction with the sodium sulfite. Both with sodium carbonate and sodium sulfite, if you add HCl, you get colorless gas. Colorless gas is evolved. How can you determine that colorless gas is CO2 or SO2 means? If colorless gas passed into lime water turns to milky, then indicates it is CO2. If lime water not turns to milky, then you expose a dichromate paper. Dichromate, it is an orange color. That orange color dichromate paper turns to green, that indicates it is the sulfur dioxide. Already we are studied in the properties of the sulfur dioxide. Similarly, you can consider HCl will decompose sodium bicarbonate. HCl decompose sodium bicarbonate into carbon dioxide. That is NaHCO3, sodium bicarbonate plus HCl. You get colorless gas, carbon dioxide, CO2 gas, then NaCl and H2O. Reaction get balance. Then HCl reacts with ammonia. HCl is acid. If you reacts with the base like ammonia, you get dense white fumes. Then that dense white fumes are due to the formation of the ammonium chloride. Dense white fumes. That is in the detection of the chloride radical. To the salt, if you add concentrated H2SO4, you get a colorless gas. To that colorless gas is an HCl. To that colorless gas, expose a glass rod dipped in ammonium hydroxide. We can observe that dense white fumes. That dense white fumes are due to the formation of the ammonium chloride. These are all important one. This HCl reacts with ammonia. Dense white fumes of ammonium chloride is formed. Then HCl reacts with one more very most important one. HCl reacts with iron. We get only ferrous chloride. Ferrous chloride is formed, but not ferric chloride. To the iron fillings, if you add HCl, you get only ferrous chloride, but not ferric chloride. That is HCl, Fe plus HCl. The ferrous chloride is FeCl2, liberating H2. That is 2HCl. This is ferrous chloride. Why only ferrous chloride formed but not ferric chloride means? Because here hydrogen is evolved. Hydrogen is a reducing agent. This reduces ferric chloride, FeCl3 into FeCl2. If any ferric chloride is obtained, that hydrogen is a reducing agent that reduces ferric chloride into ferrous chloride. Hence, to that iron filling, if you add HCl, only ferrous chloride is formed but not ferric chloride. This is important for the 1 mark question, 1 mark reason. Why HCl reacts with iron fillings, ferrous chloride formed but not ferric chloride means because during that reaction hydrogen is evolved. Hydrogen is a reducing agent that reduces ferric chloride formed into ferrous chloride. This is about the HCl. Next you can consider in the next class you can study about the oxoacids of the halogens.